equals or xyz equals. Okay, so we'll do a to b. We'll do a b. So how do we get from a to b?
2, 0, minus 3. I'm sorry, 3
Oh.
minus 2 minus 6.
Okay, so a to b is
Minus 2 minus
2.
minus 1.
And then it's
2 minus 1.
Yeah,
So it goes 3
2 minus 0.
minus 2,
Well, always I get.
and it goes minus 6. That correct? So how do we get from minus 1 up to 2? We go 3.
Wouldn't that first point be negative 1, 2, 3?
Oh yeah, so I haven't put that here because that would be incorrect here, wouldn't it?
Yeah.
Yeah. That is the vector, the direction vector, not a position vector. So which position will we use?
I use B because it's a 0.
Oh, okay, let's use B. So you can use either of them. Plus t times, if we remember how to do this,
3 minus 2 minus 6.
3 minus 2 minus 6. So that's the equation of the line. How do we use that to find where it crosses this plane?
Don't we take the equation of the plane and substitute the x, y, and z?
Yeah, so if you want to find where two lines cross, you would find where their x values, y values, and z values are the same. So we don't have, this is a bit messy, that's why it says to put it in parametric form. So if I split this up into its parametric equations,
X is 2 plus 3t.
we have values, all the values for x, y, and z, all along the line. There'll always be these values with some parameter t. I'll put minus 6t here, minus 6 times t. Okay, they're all the points along the line, and we want to know where they match this line,
So would we turn that?
or this plane. Sorry?
Would we turn that into parametric?
That's kind of hard to do.
Yeah, but what we can do is that we can substitute in, at some stage,
Oh, yeah.
it'll work out that it is equal. And when it's equal, it's that point that it's on the plane. Hmm?
Should it be equal?
No, it'll be equal at one very specific point. Will it unequal? Everywhere else will not equal 36 or 26. Everywhere else will give a different value when we sub it in because it's not on the plane.
Do we have to calculate the coordinates too?
Yeah, you'll have to calculate the coordinates.
If I have t, do I just sub it?
Yes, you need to get the coordinate then. Hence, so a point is where the line meets. So if I sub in these parametrics, I can solve for t, and that t will give me that place along the equation line where it's exactly on the plane. How far along, the t value will find it. So I'm going to sub in into this, x, y, z. So I get 2 plus 3t minus 2 times minus 2t plus 3 times minus 3 minus 6t is equal to 26. This will give me an answer for t. That'll tell me how far down the equation I need to go. So this is a simple solve. Hopefully you can do it quicker than me. I'll do it with...
What is 3 times 9?
Minus 7, 6, and 21.
I did not write the answer. So I'm going to have to do it. 7, so that's minus 7.
Minus 11t.
It's minus 11t, yeah? And that's minus 7 added over 33. T is 3. T is negative. T is minus 3.
Minus 7, 7, minus 20.
I always do this.
Oh. Negative 3? Negative 3, are we all there at negative 3?
I had 33.
33 is equal to 11t, though. Negative 11t.
Where's 11?
Negative 18 plus 4 plus 3.
Oh,
Okay, once we have t, then we can sub it in to find that place. So we know x, y, and z are going to be, or you can use each individual one if you prefer, but that t value is the only place along this line where it crosses. This is the t value. You can think of it as time if you want. So x will be 2 plus 3 minus 3, y will be minus 2 minus 3, and z will be minus 3 minus 6 times minus 3. And that will give us a point. The x value of the point is going to be 2 minus 9, which is minus 7, 6 and something. 18 minus 3, 15. Is that what you got, Abby?
Huh?
Add your
I
minus.
get 15.
Oh, I could be wrong.
Wait,
Looks right.
is it minus 6?
Yeah, it's
Yeah,
minus.
Oh, it is minus 6, sorry.
All right. So if you have it in an equation in parametric form, you can just substitute it into the equation of the plane and find out at what point along the line it goes through. Because at some stage it will go through. We just have to find out where.
Minus 7, 6, and 15.
Yeah.
I just had my 6 symbols flipped around.
Unless it's parallel, right?
Oh, yeah. Okay, of course. All right, suppose n, all right, let's do the second question. So we got, suppose n is the foot of the normal from A to this plane. So you got some point A, which is at 2 minus 1, 3. This is point A. And n is the foot of, n is here. N is this point here. N is a point where it hits the plane, it looks like. Suppose n is the foot of the normal. So a normal is at a right angle, so I can make that right angle here to the plane. And the plane's equation is this, x minus y plus 2z is equal to 27. Find the coordinates of n. Once I have the coordinates of n, I can get the distance between these two. It will be the shortest distance because it's a right angle. Okay. I'm removing this. If everybody's okay with that.
So A equals A by
Hmm?
A.
It's not as simple as that, I don't think.
Okay. So it'd be really nice to know what the normal vector to the plane is. What is the normal vector to the plane?
Can you just solve for it?
A to M. A to M.
Remember how we formed those equations of planes? How did we get this left-hand side, the x, y, z? What did we multiply it by?
The normal.
So what is the normal vector to the plane?
Oh, it's the coefficients. Oh.
So the normal to this plane is already there. It's not, it's kind of hidden. The normal is 1 minus 1, 2. Because when we do the formula, it's n dot or, isn't it, on this side?
Yeah.
And or is xyz. So xyz. So what has it been multiplied by? It's multiplied by 1 minus 1 and 2. So the normal to the plane we have, it's in there. All right. So we have the normal to the plane. That's very useful. We kind of need to follow what we just did. Intersection point, I need to get what's the equation of this line?
Well,
What is the...
it will be 2 minus 1, 3 plus the normal, right?
Okay, so the equation of the line now joining A to N.
Is N to A. Or as well.
Hmm?
Is it N to A? No.
Oh, yeah, you can go. Yeah, N to A might make more sense. Yeah, considering it's going that direction. Yeah, N to A. The equation of that line has a position. We have a position on the line, 2 minus 1, 3. And we have the direction of it. It's going 1 minus 1 and 2. As soon as we have that equation of the line, we can do the same process we did last time because we have the equation of the plane and we want to know where x, y, and z are the same on each by subbing in. So we have our parametric equations, 2 plus t, y is minus 1 minus t, and z is 3 plus 2t. They are three particular values that we can sub in for x, y, and z in the equation of the plane. So we're going to sub that into this one. And it will only work in one position, and we're going to find that now. It'll only work for one value for t. And that's what we'll find next. So sub each one in, 2 plus t instead of x, minus 1 minus t instead of y, 3 plus 2t instead of z, and we solve again for t. So let's see, can you finish this one this time? So you're trying to finish it, as in get the actual coordinate of n, and then find the distance between those two. is t3? That's a good question. T is 3, yes.
9 plus 16 equals 27.
So remember, you have to get the distance then. That's the final answer to the question, not the point. So you're going to have to get the point and then the distance.
Wait, how'd you get 3? I got the 16 equals 30. Oh,
Subtract the 9.
yeah, equals 18.
What do we do after this?
Okay, so we need the actual, what's the point here?
You sub in.
So I can sub into my equation at once, what stage along the line is t3? And then you put in t to be 3.
5 minus 4 and 9.
So I can put it in here if you want. It might be easier. X plus x. The x coordinate is 2 plus 3. The y coordinate is minus 1 minus 3. And the z coordinate is 3 plus. That's not the final answer though when I get this value. I want you to get the final answer before me, hopefully. You're looking for the distance between those two points. Okay, off you. The modulus of what?
So the distance from A to the plane, which
Yeah.
is 5 minus 4 and 9.
Yes,
and
the
you
distance
multiply
from
that.
A to N. How do we get a distance between? Yes. Minus square root. Like a big Pythagoras theorem. So the x coordinate is 2 plus 3 is 5. Oh, let's write it as a point so we don't get too confused.
Wait, so we do mod that point.
5. We want it, of course, to get the next bit. 6. So 5 minus 4 and 9 is our points. I need to find the distance then between A and N. So how do I get the distance between A and N?
Is it not just root 54?
I actually don't know what it is, so I'm going to do it now. It's the square root of one subtract the other. It's the distance formula. 5 minus 2 squared. So the distance between the x's,
Oh, so it's 3 minus 3, 6.
minus 4 minus 1 squared plus 9 minus 3 squared. So I'm just 5 minus 2 minus 4 minus 1, just using the distance formula, the three-dimensional distance formula.
Why would you do it inside the brackets when you could do the distance between the two outside the
What
square?
difference does it make?
Oh, we will.
It just works easier.
For you, sure. Maybe
3 squared plus minus 3 squared plus 6 squared will give an answer of something. 9, 9, and 36.
It's
54, thanks. Yeah, 54. Is that might have a simplification going on. Is it 3 root 6 or something?
3 root 6. 9.
Isn't that 9 times 6? Yeah, 9 times 6.
Do you really have to simplify?
Oh, it's just nice.
Doesn't have-
Units?
Yeah.
Oh yeah, units.